really cool, but really tricky. This one's really actually very feasible. You want to read the full thoroughly. I'll read the pack. Really interesting.
All right, welcome back. So I see that several of you had tried to get your OpenShift up and running. Anybody was able to do that yesterday? A couple in the back, maybe a couple of you. If you could, please get that going as fast as you can. It's you might run into some issues that I'd like to be able to get cleared up before the end of the week. All right. So today this is May 10th. We are still in the first week. We'll be together. Let's see, about 7 weeks, and the last week it'll be dedicated for project evaluation. You should all have already been invited to Piazza. Has anybody not received an invitation from Piazza? Anybody? Okay, so everybody's on Piazza, right? All right, great. If you go on Piazza, one of the links there is in the resources, and if you go under resources, I'm going to put several links here, but one of the more important links here is the course website, which will take you to this website over here. Okay, so if you're invited to Piazza, you should have access to the portal. Okay, in the portal, as I noted yesterday, one of the links here will give you access to all the videos. Two playlists here, one for this section, CS4550 on the left-hand side, and one for CS5610, which we meet on Tuesdays and Thursdays. It'll be the same material, but this one will be a little more spread out, right, over 4 lectures a week, whereas that one will be 2 lectures a week, so a little more condensed on the other one. And right now we're recording. The video should be made available right at the end when we finish. Gets automatically added to the YouTube playlist. It should be available here. Please let me know if you can't see it or if the audio, you can't understand the audio. Just please let me know. All right. Okay. Also, these are on the left-hand side. You can see the various modules for the course. Right now, the first 2 modules are only available. The developer environment, which is the one we're currently working on, which is setting up the environment, and hopefully by the end of this week, we'll all have a working environment, a local working environment, and also a remote server all running by the end of this week. And please make an effort to maintain both systems synchronized. Don't have that. Don't let it happen that you're working feverishly in your local environment and you let the remote site get behind and not sync. So please make sure that you have both synchronized. We went over the assignment yesterday. I just want to go over it real quick again. Make sure we don't miss anything. So this assignment is going to walk you through setting up the development environment. Right? There will be a local. We're going to have Node.js and the database running on your local machine, and then you're going to have a remote environment, right, which is going to replicate your local environment, but running on OpenShift. Okay. So locally, you're gonna install Node.js. We went over this yesterday. You can go to the download site, and there'll be one for each version for Windows or Mac. Doesn't really matter which version. You can try out the latest version, version 6. Although I would prefer to say maybe version 4. But if you want to play around and experiment. We're not going to use any of the advanced features of Node.js, so we should be okay even with the latest version. So this install is really easy. It's just going to add a couple of command executables on your path, just node and npm. So try them out. I see that 4 of you already have tried it out and was successful. I think somebody had a problem yesterday on Piazza. What was it?
I have a Mongo post,
Okay, the Mongo.
but the sudo command worked.
Okay, okay. So some of you on Mac, you might need to run with a sudo command to provide your credentials to run either MongoDB or Node.js locally in your machine. All right, so we went over this yesterday. Also, somebody, you ran into an issue where, was it you, that because you had started maybe Node.js before the database and you didn't find the database, was that it? That was you?
Yeah.
Yeah, and that it worked?
Yeah.
Just restarting the server worked, right?
Yeah.
Okay. Yeah, the server, when it starts up, it looks for the database, and if it doesn't find it, it complains, right? So even locally, please start the database first, right? And then start the Node.js, because it's going to look for the database connection right away.
Once you run like the MongoDB once, will it always be good? Or we have to run it again?
When you restart the machine, you'll need to restart it. Although you can set it up as a service so that it restarts every time you restart the machine. But unless you're gonna do heavy development only for mean stack, then yes. But for just this course, just restart it. Okay. So yesterday also we went over installing MongoDB. Node.js is a little easier because it already installs all the tools right on your path. MongoDB does not. Right, you'll need to unpackage it, and you'll need to add the bin directory to your path. So I give you a couple of examples on how you would do it on a Mac. Right, you would need to once you install Mongo, if you unzip it to say this directory, user local Mongo. Yes. Is it? Oh, Homebrew, you could use Homebrew to install it, yes. Yeah, all that, thank you. Yes.
In this export path equals user, you need to put Mongo, or you need to put whatever location it's in. So we're right before /bin.
Yep.
That should say Mongo.
Oh, yes, thank you. Good catch.
And depending
Yes.
on where it's placed, you might have to do a bash profile.
Yeah. Right. You should all have a bash profile, but some of you, if it's a brand new machine profile, you might need to create it. You might just say touch and then .bash profile will create the file, and then you can start editing it with your favorite text editor. But yeah, it should be in your home directory, right? And in there, you can export. You can add to the path, to the system path, you can add the bin directory so you can run MongoDB right from anywhere in the in terminal, right? Please, if you come see me, make sure you have these settings all set up so that I can help you. Help me help you. Have these things already set up whenever you come see me at office hours. Also, you can try it out by running MongoD. Right, so MongoD is one of the many executables under that bin directory. Right, that is the executable that will start the database up and running. It'll start up and say that it's listed in a particular port and that it's going to be storing all your files under the /data/db. Okay, so also I think I said somewhere else that you need to create this particular directory where it's going to store all the database files. Right, it'll say that it's waiting on that port for connections. Also, most of you already had this, but just let me reiterate that you'll need a Git a client. Most of you did already. And if you have a Mac, it should be already installed on your machines. On PCs, I suggest one of these clients. I also provided a template project, right? And which you can clone down from Git. The template is available at this directory, at this URL. Okay, I think like 4 or 5 of you already did this, right? You clone down this project. It'll copy it locally on your machine, and you should be able to run it right from within your local machine. It's a very simple, bare bones application, just to try out and test that your environment is up and running locally and remotely. Also, it has some of the structure that we're going to be requiring from you, right? That you do all your project work under a particular directory, your assignments in a particular directory, okay? Just to go over real quick on the structure, this server.js file is the file. It's a JavaScript file, right? That represents the configuration of the server, right? It's what starts the server up and running, listening to a particular port. Okay, it's friendly to the local environment. Also, it can be run on the remote machine. I'm just going to go over real quick. I'm not going to go into too much of this, but real quick, it's a JavaScript file which is meant to be interpreted by your local Node.js installation, right? So to run this, you would say node space server.js. Right, and that starts up the server, right? It requires one of the more popular libraries, which is Express, right? Express is one of many libraries written for Node.js, right? That makes it very, very simple to create a server, right? Listening at a particular port, right? With 3 lines of code, you have a server up and running. So the only lines you really need here are requiring the Express library, creating an instance of the Express library, and then this last line here that says listen for incoming requests at this particular port at this particular IP address, right? Everything else is some additional code that I added so that this file can be run locally on your machine and it can run remotely on OpenShift. Okay. In particular, it's these lines right here. These lines right here are asking, am I running locally on my machine, right? Or am I running on OpenShift? Okay. This checks to see, look up the IP address, right? If there is one. Check to see if there's an environment variable that is called Node.js IP or Node.js port. If I can't find it, right, default to 3000. So it's this or that, right? If this is true or truthy, right? If it's not false or undefined or null or empty string, it'll take this. If this is not truthy, right, it'll instead take 3000. So at listen over here, we'll either listen to the local port and local IP address, or it'll run on OpenShift. So this allows you to run locally or on OpenShift. Okay, this line of code right here. Yes.
So how does the OpenShift Node.js IP exist? Is that there once we install Node.js?
Yeah. So there, when you request a machine to install it remotely, it has all sorts of environment variables already installed, set up on that machine. Okay. So for instance, if when you install MongoDB, the username of the database, the name of the database, password, all the IP address, the port where the database is running, is all configured by environment variables, right? So you never have to, for instance, actually use the password and the literal values inside your source code. So that source code is never those kinds of secret information is never actually available literally on the source code, right? And we're going to be using process env for several other things, such as when we start connecting to web APIs out there, like Yelp or Facebook or IMDb, right? They will require a secret, right? A password, secret, clients, phrases. And all those things, they require us to submit that information whenever we request information, we request data from this API. And we never want to put the source code or that information as part of your source, because look, it's publicly available, right? All this is publicly available. We don't want to make any of that viewable for anybody. So instead, what we're going to be doing is something similar to this. Is we're going to create environment variables where we store all that information either on outside files or environment variables which can be read in from the code like this. Okay. Another couple things that is configured here is this this other line over here that says app.use directory name public. What this is that it's declaring a local directory called public, right, where you're going to host anything that is static, right? Any static content, right, will be stored, can be served from that particular directory, right? We mentioned yesterday, right, that servers can be configured to, just serve static content, right, such as HTML, CSS files, JavaScript, right, any right, all that is considered to be static from the point of view of the server. That is all static content, right? So this configure is saying that anything you drop in that directory is publicly available, and that it's accessible by providing path in the URL to that will map to those static content, right? Everything else here, I'm not going to cover right now. I'm not going to cover this right now. This is part of the test, right, to see that your server is up and running and the database is running. And I'm not just ready to cover that just yet. Okay, let's see. Another thing that is important here is this package.json. I can't stress enough how important this file is. Okay, this file is what's going to allow the environment to be compatible with your remote environment. Okay. A lot of you are going to be starting to do a lot of coding, not just yet when you get to the server development in a couple of weeks. So it's not relevant just yet, but it will be. But I want to keep reminding you how important this file is. You can install several libraries, right, that will allow you to do HTTP connections and connect to Yelp or connect to all sorts of APIs and all sorts of things that are connect to databases. And it's going to run beautifully locally on your machine. You're going to do npm install library, right? And it's going to run locally beautifully, and you're going to publish it remotely on your the remote machine, and it's not going to work. Why doesn't it work, right? Well, it's because this is how the remote server knows about your local environment. This file describes your local environment, what dependencies, what libraries you have installed in your local machine. Okay. If you want to connect to Yelp, you can do npm install Yelp, whatever, right? If you want to connect to Facebook, you can do npm install Facebook, whatever, right? The APIs for each library or anything that you want to use. And when you install those things, right, they're copied locally in your machine. But when you publish this to the remote machine, the remote machine says, hey, you're referring to all these libraries, but I can't find them. I don't have them, right? And the way the way to tell the remote server that we need all those libraries is to declare these as dependencies, right? So this dependencies over here is where we declare any libraries that you might be using, right? So how do these make it into here, right? These dependencies. It's very easy. Any new library that you need to install, like for instance, I installed a couple here. I installed one to create the server and one to connect to the database, right? These two libraries. I'm not going to cover this just yet. So to install it, because I needed those libraries, at the command line, I use npm, right? Remember we talked about npm yesterday. npm is Node's package manager, right? It allows you to very easily install new libraries that you need in your Node server, right? So you would say npm Node package manager install. Okay, then the library. Okay, that's all I need locally. That's all I need locally, right? This will go off, connect to the npm server, right? It will download the Express library and it'll install it locally on my machine. Okay, and it copies it locally on a particular directory. But this happens only locally, right? Installs it locally in our machine, right? For the remote server to know that your code depends on this, right? You need to add one more thing. Right? You need to add -- save. Sorry, it doesn't fit. So npm install express -- save -- save. Right? I'll be repeating this over and over. Right? It doesn't matter just yet. So, but in a couple of weeks it will matter, right? And I just want you to have you this in your brains about that. Right, because it happens a lot, right? That when we start looking at Node.js, but it's not running remotely. Right? Everything's working fine locally, but not remotely. So yeah, so this -- save, right? I'll remind you when we get there. Well, what this will do is that not only it will install that particular package, that particular library locally in your machine, but it will also add it here in this package.json. It will make an entry into this JSON file. Okay? It'll make an entry here. It'll, for instance, this entry right here was because I added a -- save. It added the entry of that library as a dependency to my project, right? So when I then publish my project up to the cloud, to my remote server, the remote server is going to open up this package.json and says, I need to install Express. I need to install all these libraries. Yes? If it doesn't find it here, it will not install it. Right? And it will fail. It says, I can't find this library, I can't find this, that, or the other. Everybody okay? Right? All right. Yes.
Does the server reinstall the file?
It does. It blows away the environment and reinstall.
That's why you have this, because if you could just install it
Yep.
on the server and let it sit there.
Yeah.
This is what stage.
You already did the npm install express regular. If you do -- save, you do it again. You do -- save, it'll save it properly.
Yes. Right. If you had done it, installed it once without the -- save, right? If you do it again, right, it'll just do the entry into that package JSON. Right? So you could save yourself by just doing it again with -- save. Okay. All right. So under public directory, here's where we're going to store our public content, right? All HTML, CSS, JavaScript, images, right? Anything that we put in here is going to be publicly available to anybody who visits our website. Okay? And this index file over here, that index.html, that is the root of our website. Okay? That is the default file that gets loaded, right? And that name is a special name, right? It has a special meaning, right? Like the name suggests, is the index to the rest of the website. Well, at least the index to this directory, right? It says what's in this directory, but it allows you to create links that allow you to navigate to other parts of your website. And here we have two directories in particular. One is the assignment directory, and the other is the project directory. Okay? And in each one of them, you're going to be building two projects. One where I'm going to handhold you, right? We're following the assignment. You're going to implement an assignment. And ideally, what you learn from the assignment, you'll be able to apply that directly to your project. Okay? So your assignment, you're going to be doing it all inside of in this directory, the assignment directory. Oh, before I get in there, this index.html is what I refer to as the homepage of your website. Right? That is what's worth, what is it, 8% or something? Right? That index page, right? Again, it should look spectacular. It should have links to your project, to your assignment, to your GitHub. If you have documentations, videos, yes.
Is it okay to add CSS in that directory?
Yes.
Folder?
Yes. Right. Other directories that are very right and put dedicated resources under those particular directories. An image folder would be very appropriate here. Okay. Right. Then, as the assignment is going to be is going to come out next week, the first assignment to implement something, asks you to assignment directory. This is the assignment directory that it refers to. Okay, you're implementing your assignment under this particular directory, right? And this index file, right now it's very simple index file. This is going to be you're going to be modifying this, right, as I ask you to in the assignments. I'll show you what you're going to be building in a minute. Okay. You're going to be replacing this with what you need to implement the assignment. And remember, we're using a source control. Once you reach your completed a particular assignment, you don't need to wait for it to be graded. You can keep going on to the next assignment, right? Because we can always go back in time, right, to a particular spot in time where you submitted. What I do need is for you to tag, whenever you have completed an assignment, you have to say, this is assignment 1. This is what I want you to grade. Okay? I need you to tag it for us so that it's a deliberate, a formal to the TAs and myself. And in your project, this is it mirrors the assignment. You have a very simple index file, right? This is where you're gonna have your project homepage, right? This you can do whatever you want in here, right? It's your project. You within the guidelines, right? Of what I'll let you know. But in general, it should be within as complex as the assignment that I'm going to show you, right? It should be as complex as that. But the overarching policies is that it should be phone friendly, right? Mobile friendly. That's the first thing I'm going to do, right? I'm going to view your weird wrappings, right? Can I pinch and zoom, right? Does things collapse so that it provide navigation through maybe a hammer or a collapsible menu? Right? Does it have paddings and white spaces so that it's usable on a phone? Under test, this is a piece of code that I wrote real quick so that to test your application to see if it's up and running and that it's connected to the database. What else? Oh, git ignore. All right, so this git ignore is fairly important, right? It's a file that it's meant for to be interpreted by Git, right? And it has 2 entries in here. And the way it works is whatever you put in here, Git will ignore, right? It will not try to copy the content of either those directories or those files onto the source control, right? 2 of them are very important. One is node_modules. This is a directory where npm, when you do an npm install, it downloads all those libraries, it copies them on your local environment, right? It installs it under that directory, node_modules, right? And that folder it's going to be the same for all of us, right? So if you install Express and you install Express, it's going to look the same for everyone, right? It's kind of wasteful to have this copied over and over for everybody, okay? So it's really not appropriate to copy any of this content to source control, okay? Instead, what the server's what's going to do is that it's going to look at package JSON, right? You're going to see all your dependencies, and it will install anything that it needs from your dependencies. See that, right? So there's no need for us to upload any of those libraries. This one is a directory that is used by your IDE, WebStorm, right? And in there, install it has a whole bunch of XML files for that configure your IDE. That also is not interesting for our project, so I put that ignore in there. If you're on a Mac, you might want to add a couple more things here. Mac creates all these thumbnails, all these thumb images in the file system. You might want to add that here so that is not copied also. Anyway, what else? What else? That's it, right? Okay. All right. Okay, so here I walk you through installing the template. I'm assuming that perhaps you're installing in your home directory. So this means home directory. So in your home directory, perhaps you have a directory Summer 2016. If not, create it. And in there, I ask you to clone down the template that we just went over. It'll create a local copy. It'll create a directory called web dev templates. And in there, if you do an npm install, what it'll do, this is exactly what the server does. This is what OpenShift does, right? When you push your content onto OpenShift, it reads the package JSON, right? And it does an npm install. That npm install is going to read your package JSON and sees that, oh, I need Express, I need what else? Body parser, I need all those libraries, right? It'll install all the libraries, and it's good to go. Once it's installed, right? You can do a node server JS, and boom, it'll start the server listening at port 3000. 3000 is a very common port number that is used by mean stack developers. So if you do a localhost 3000 on your browser, it'll bring you to the sample application, right? And it looks something like this: web dev course homepage, and the links, project, assignment, test MongoDB, and your public repository. Obviously, this link is pointing to my repository. I need you to change it so that it points to your repository. Okay, please point to your GitHub repository. Also in here, you will add a link to a 5-minute video, or 5 to 20 minute, no more than 20, please. Video that you'll be able to demo your project, right? Highlighting, putting your project in it's your best light. The test MongoDB, to try out that if the MongoDB is running, if you click on test MongoDB, it allows you to just post some test messages to see if it's storing in the database and it's retrieved from the database. So we're going to try it out. The TAs and myself are going to try out, posting a couple of things just to see that you did install the MongoDB remotely. GitHub. So yesterday I asked you to create a Git account, but most of you already had a Git account, which is great. Some of you, I believe, told me that you have private Git accounts. That's fine. I need you to invite the TAs and myself as collaborators to your Git. Remember, we're going to use Git so that we can track what you're doing, right? We can track your, yes? Yes.
It's a work I run on God first, and I ran server.js.
Yeah.
Oh, really?
Yeah. So I couldn't just run server.js. I do it on God first.
The install order will matter. It's that you have to make sure Mongo's run
In the background.
Yeah. Yeah. Thanks. Okay, so basically what happened, right, is that this is my Git. This is my Git, right? And here's your machine. And what you did is you cloned down the project here from my Git. And then what you did is you're going to copy to your Git, right? So you're going to have your own Git. So this is my Git, right? And this is your Git, right? So you're going to do you did a clone, right? And here you're going to do a commit and a push, right? And it's now available. And I need you to invite the TAs and myself to this Git account. Yes?
Why not just,
I'm sorry? You can do that. You can fork it. Yeah. Yeah, fine. And yeah, I'll need you to invite us to that Git. Right, so my username in Git is Giannuzzi. The TAs have not yet posted their usernames in Git. Right, so then you're going to set up OpenShift. Most of you already have done this. You can create an account at OpenShift. Once you open an account, This will be blank, right? Because you will have applications on OpenShift, but you'll be able to create an application by adding add application. Of applications that you can install: JBoss, WordPress, Ghost, Tomcat, PHP, Ruby. There's a whole bunch of them. We're going to be using a Node.js application. This one right here, Node.js latest. Okay. If you click on that, it'll ask you what do you want to name it. So I believe what I've asked for you to use the name here, just to make it easier on us, is to use your last name, first name, and then webdev, right? So that we can quickly identify you and see whose website it is. You can keep the defaults, and when you install it, it'll create an application. Right? We'll create an application for you. It'll take a minute or so. So a sample application might look something like this. You'll have an entry right here, just like this, right? If you click there, this is the dashboard for that particular application, right? Also need to install MongoDB as a gear. It'll be a link here that says add MongoDB. When you click on that, right, it'll go on and install MongoDB. It'll provide the username and password for the database. You won't need it, only if you're going to use a client to log in and see the database content. But for the most part, you're not going to need the username and password. But I would copy it and keep it aside if I ever need to connect to it with a client. Okay. What you will need is this right here. Okay, this SSH right here. Okay. This is OpenShift's Git. Right. This is OpenShift's Git, and this is how you publish your content to the remote server. Right. Just like you push to Git, you can push whenever you're done, whenever you feel that your project or your assignment is at a stable state, you can push to and deploy to this URL right here. Right? This is let me copy it. Right. So this is a Git for my for my application. Right. It's just like the URL in GitHub, exactly the same thing. See, it says .git at the end, right? So it is a Git repository, right? So to publish your contents to the remote server, right? What you would do is that you would say, just like you did for GitHub, you can do the same thing, right? Once you're happy with it and it's stable and there's no bugs, and you can say push, and then it'll push it to OpenShift using this URL. What else? Don't publish before installing MongoDB. Right, so first install MongoDB, right, and then publish. Right, because when you publish, it's going to try and connect to the database. Right, it's going to start the server, Node.js server. The Node.js server is going to try and connect to the database. It's not going to find it, and it's going to complain. Right. If it does complain, you can restart the server by clicking on this icon. It'll restart the server. Okay. What else? Right. So this is I'm suggesting you use this this naming convention, webdev, and then your username. You'll need to install the development environment. This is Red Hat's development tools. Okay, what this is going to allow you to do is debug the remote server. Right? For instance, if you want to look at the log files of the remote server, if it crashed, you want to know why it crashed, right? You want to look at the logs. These tools will allow you to do that. It allow you to tail the files as the server is running, right? Which is a great debugging tool, right? It allow you to set environment variables, right? Remember, we set locally. We might anything that is private information, such as passwords or secrets or anything like that, right? Passphrases. Those things we don't want to put in source code. We want to put them as variables, right? Well, locally, we can do that using either Mac's bash profile or Windows environment variables, right? But remotely, what we're going to need these tools to be able to set remote environment variables, right? Alternatively, you can also do an SSH and SSH right into the server, right? And you can have just do a SSH session, right? And you can see all the files and everything there. But locally, you can do it using the tool RHC tools. So yeah, this is the website. I need you to go through this, right? Depending if you're on Windows or Mac, you can install the tools following these settings. I know that already some of you have already done this. Let's see what else. Okay, so here's how you publish the content that you have, how you publish it to OpenShift. This is the push. This is the commit, the first commit to the server, and then this is the push and copies all your source code and deploys it to the remote server. This is a command that allows you to tail, right? If you have an error, this is how I debug. Is it yours? Somebody's, yeah. So I was failing, I don't know why I was failing, so I did an RHC tail, right? And this just lists the log files of the server that is running live. You can see what's happening remotely. And it said, I can't connect to the database. It says, I'm missing the database. So I did a quick restart. Keep me awake? Yes?
About so a question to OpenShift and GitHub.
Yes.
How would we write the script to push the
You could do an SH script, right? Or bat file, directory, right? Call it push, right? And one would do, git push OpenShift and git push GitHub.
Would there be a way to give arguments to that? So we just run push and
Yeah, you
give
do
a
that.
git message and OpenShift message? Or just
You
one
can
message
do that.
forward?
You can do that, although Git already does that, right? You can say git push and then the name of the remote. So I don't know that you would win. Although I don't know that you would want to deploy to the OpenShift server as frequent as you would to the GitHub repository, right? So typically, you might want to do very frequent commits, right? You code, right? You make a feature work, you commit. You work another feature, you commit. Right? You do frequent commits. That's easier, right? So that if you do run into trouble, you can always backtrack to a previous state, right? Right? Otherwise, if you code 20 files, you've changed 20 files, and you run into an issue, you don't really know what happened, right? So do frequent commits, and at the end of the day, you do a push. You do a push to both. What this allows us to do is the TAs and myself could quickly, help you debug something, right? Yes. Yes.
When I try to push to the OpenShift, it's that it's rejected because the remote has some work that I don't have local.
Right. So if that happens, right, you can always force it. That has relevance if you have several developers working on the same project. It might happen that some works and got ahead quite a bit ahead of you, right? And you don't have those changes from someone else, right? And so typically what happens when you have many folks working on the same project, right? You want to make sure that you're all synchronized, right? That we all have the same source code, right? But it often happens that somebody goes on vacation or whatever, one is lazy and it doesn't pull all the changes, and you have to merge. Make sure that you have conflict source code, right? But if it's just you, right, and it's your project, you're not conflicting with anyone, you can just force the push. It says, no, I don't care what's there. I want to override what's there. Okay, so when you do a push, and it's OpenShift, right? it's OpenShift, you can say dash dash F, force. Meaning, yes, push it, I don't care, override whatever's there. Okay. Does that work? Yeah, okay. Right, so the WebStorm IDE. Yeah, so I asked you to please download the WebStorm IDE, and it is a JetBrains tool, and it's free for students and faculty. If you have an EDU account, I ask you to please, let's all standardize on WebStorm. It'll make it easy for us again to support you. With the really cool thing is that it allows you to do breakpoints. You can step through the server code. You can also step through the client code, right? So, and I would ask you that before coming to me, to please make an effort to debug it somewhat. Okay, put some breakpoints in your server. Make sure that it is getting to the server, that it is getting to the code in the server. And that you step through it and you can see all the variables, you can see all the values. So WebStorm is a really nice tool that allows you to debug and do server-side development. So yeah, so the only thing that I'm going to ask you in Blackboard, the only deliverable that I'm going to ask you for is to provide the links to your OpenShift, in that index file, right, where the homepage of your project, and also the GitHub URL, right? We'll just need those two things, but don't submit any files, right, to Blackboard. Yes.
I haven't put someone.
I
have to be outside.
Oh, maybe. Okay, maybe I haven't made it available then. Okay, I'll make it available. It's there. It's just I think I need to make it visible or something. Yeah. Yeah, I'll make it visible. All right, so I'd like to demo the assignment that you're going to be working on. This. Okay. So you're going to be implementing an application that allows you to build applications, right? Or allows you to build websites. So you'll build a website that allows you to build websites. Somewhat like an IDE, right? But an IDE that you can use right on your phone, right? That you can build mobile web applications. So here you have a login page. Alternatively, we would have a homepage that with a lot of marketing, that some pretty pictures that entice you to go and use the application. For this assignment, for the first assignment, I'm not going to ask you to do that. I'll ask you to implement just the client side of this, right? Create only the HTML, only the CSS, right? Just some very light JavaScript, right, for the first assignment, right? But you'll build the first couple. We'll demo for you. Okay. So this one allows you to log in either with a username and password, or also log in as either with Google or Facebook login. Right? So we can delegate authentication to a third party. Right now, for the first assignment, I'll ask you to just focus on just a plain old login, right? Login and registration. Registration allows you to provide a username, password, and verify the password. Okay. So let's create a user. And when you register or when you log in successfully, you're taken to the profile page. And the profile page, oh, you can't see the contrast. You can't see the. Why can't? That's weird. Okay, it's supposed to look like a phone. It looks okay on my machine. Anyway, so you come here to the profile page, and the profile page allows you to set some personal information, so first name, last name, perhaps also email and phone numbers and things that are personal to that particular user. And it follows why is it not? Wait a minute. 100. That's weird. It doesn't let me scroll up on this. It follows the design that you have at the top. You have a header, a checkbox on the right that is kind of like an OK, right? It's a I'm done, or it's like a save state, right? And it follows that same design throughout. Also on the bottom right, there's a footer, right? Very well defined, that has an icon that allows you to come back to this profile page from anywhere in the application, right? Also, from here, from this profile page, we have access to other things that are related to that particular user. In this particular case, its only relationships are to its websites, that person's websites, right? But other things that might be here that are related to this particular user are if they're following somebody, right? So I could see maybe people that I'm following, or if somebody's following us, that also is related to us, right? Maybe any messages I've sent to someone, or any messages that I've received from someone, right? Or if somehow I'm sharing any other information with anyone else, right? So the profile page, in general, right, should give me access to anything that is related to the person who is currently logged in. Right now, we just have websites, okay? And this particular user can have not just one website. I could have many websites, right? I can create many websites. So if I go to the websites, it goes to a blank page, which right now, because I don't have any websites just yet, right? But I can have many websites, yes, right? So you'll hear me say often that I want to learn how to create these kinds of relationships, right? Where you have one user related to many different entities, right? So you might say that you have a user who has many websites in this case, right? And we're going to denote this using UML, using a one-to-many relationship, right? And some of you should have seen this in databases in 3200, but I believe some of you have not done databases just yet, right? So I'll repeat this over and over as we talk about the design of these websites. But we want to learn how to do these things, right? We want to be able to create these relationships of one user having relationships with many websites. Or maybe a user having relationships with other users, right? Maybe a user is following another user, right? Right, it's a many-to-many. A user can follow many users, and a user can be followed by many other users, right? So we'd like to learn how to make these relationships, right? We can have users have one-to-many with websites. We can have users have different roles in websites, right? Maybe we can say that there's a user is the owner of many websites, or but you can have a user having different roles in a website, right? Somebody could have maybe a read-only role, yes. Somebody can edit, right? Maybe you can have several information about those relationships, right? Whether that person can perhaps give others the same role, right? You know, just like for instance, if I share a document with you in Google Docs, right? Often it allows you to submit. You know, can this person also share with someone else, right? Or can they also allow other people to edit the same document, right? So those kinds of things, we would allow you to, we would model it, right, by using this association between these two different entities, right? And you'll hear me say entities quite a bit in the class, right? Entities, I mean by anything that we need to store in the database, anything that we need to model, that we need to grab information about, right? So you hear me say these kinds of designs, right? Of creating many-to-many mappings or associations between entities. Other relationships that are that are related to themselves, right? You will hear me say also that each entity perhaps can be related to other entities, right? Maybe you could say that a website can have many pages, right? Right? And you'd be able to say, oh, there's a one-to-many right here. There's another one-to-many over here. You might say that a page has many widgets, right? A page might have widgets like headers and drop downs and labels and all sorts of things, right? A page is made up of other things, right? We'll visit this over and over throughout the class, right? On how to talk, how to use this this language, this called a UML that allows us to talk about the relationships of all the different things that we want to capture in our project, right? Whatever we're building, right? So right now we've just talked about a user and the website, right? A user can have many websites. So being here at a website, I can create a website. I have a plus sign there, right? So that plus sign presumably allows me to create a new website. Allows me to create a new website. Let's say we want to build Twitter. And a description, perhaps. Right? I say OK, and notice that it comes back to the list of my applications, right? And notice that it's listed on the left-hand side the website I just created, and on the right-hand side a couple icons that presumably give a hint that one of them is like a cog, where perhaps I can do settings, I can change settings, and this arrow, this triangle, which suggests that I can run the application. Okay. If I go back to the cog, it allows me to edit, right? To edit the application, where I can change maybe the name of the application, I can change the description, I can remove the application, right? Very similar to the new website UI, right? Also notice that I have on the bottom left-hand side, because I'm editing it, it allows me to share. So this is an icon down below that somehow gives us the connotation that we can share this application with someone, right? Perhaps I want to invite collaborators to this website to help me implement this website, right? We'll do that a little later, not for the first assignment. Also notice that each page has this arrow that goes back. It's kind of like a cancel button. Right? It says, no, I don't want to. This checkbox says kind of like, yes, okay, I'm done. And then on the left-hand side, I have this arrow that says, no, I just want to go back where I was. Right? Just go back. It's like a cancel. And notice that the design it's fairly consistent. So notice that the name of the website is it looks like it's a hyperlink, inviting me to click it. Right? Notice that it has a blue. So kind of what we have come to accept as something that can be clicked on or can be actioned on, right? Or it allows me to navigate. Now I click on it, and I go to pages, right? Because the website is made up of a whole bunch of pages. And again, notice that the design is fairly consistent, right? I have a plus, and I have a left to go back, like a cancel, that allows me to go back to my websites, my list of websites, or allows me to go to that particular set of pages. So I don't have any pages. So let's create a new page. So the basic layout of Twitter or any of these applications that allow you to post content, like blogging sites or Facebook or Twitter, is that you have like a running list of the things you've posted, right? Perhaps in reverse chronological order, right? And then you have a dedicated page that allows you to create the post, right? So let's create 2 pages. One of them will create tweets, right? Perhaps. So tweets is the list of all the tweets, right? It's perhaps the main page, right? I always look at the different tweets. And then another page that I might need is to post a tweet, right? Post a new tweet. So I'll create another page called new tweet. Okay. All right. So I have these 2 pages. Right now we don't have anything yet. Right? But if I can go and edit them. I can go back to edit them and delete them, or I can go and navigate to one of these. So I can say new tweet. So a new tweet. In a new tweet is where I'm going to post a new tweet. Yeah. So I will need maybe a title for the tweet, right? maybe the text area where I can have the actual tweet, right? So let's do that. I can add widgets to this, so maybe I can add a header. So this is a list of the various widgets, right? A header might be a widget, a text input field, HTML, buttons and images and YouTube and all sorts of things that we can post here. Well, let's create a header, and this will be, the header will say new tweet. The size of my header 2. Let's say OK. So there it is. So I have my header, my heading. And then I can create maybe a label that says, maybe call this a title. So this is what we're going to be building. I'm just demoing what we're going to be building throughout the semester, right? There it is, a label. Let me add an input field. The input field, I can configure this. Each widget has different configurations, right? So labels have text, and input fields might have how many rows do I want the text input field, right? Just 1 row, 2, 3, how many rows I want. So each widget can be implemented differently. I'll give it a name, title, and I want just 1 row. So that's the default. I don't have to place it. A placeholder. Placeholders are kind of like that grayed out text that gives us a hint of what is that we're expecting the user to type in that input field, right? I'll say OK. So there it is, an input field. Then I need the text area where I can type my tweet, right? My 140 character tweet. So another input field, but this time I want it to be 4 rows high, right? I also I want to say that it's formatted, meaning I should be able to do bold and italic and headers and some formatting of my tweet. And I'll call this the tweet, right? Tweet. A placeholder, I'll call it tweet. Okay. Here it is. I have a text area, right? Oh, I didn't remove the text. I can go back and edit and just remove the text. This is the default text that would show up, right? This is the default text. So there it is. I just get the placeholder. Oh, I forgot the label. We need kind of like a label here, right? Above this. So let's create another label here. Label, and the label is tweet. Okay, and I can move this, right, and rearrange this and put them. I thought I could. Really? Okay. On the phone is not working. I thought I fixed that. Anyway, I can rearrange the widgets, right? So I can relay out my page and move different content around. And finally, I need a button, right, to actually create the tweet. Let's say a button, and the text that I want to say is post tweet. I can set a style. Blue, primary is blue. Danger is red. Success is green. But we'll go over that a little bit later. Also, if I do post my new tweet, I want to navigate to the tweets, right? Typically, that's what happens, right? The navigation is that when you post a new tweet, where do you go? You go back to the main page where you see all of your, right? That's typically a very common navigation, right? That when you want to create a new thing, you go to create it, when you say OK, and you go back to the list, right? It's a very common navigation paradigm. I want to navigate to tweets, and I want to say OK. There it is. I have my page, right? My new tweet page. How about I go back and I edit my tweets? Tweets is a list of all the tweets. I can list. This is a list of all the tweets. So let's add here a header saying. Maybe I should have a button that allows me to post a new tweet, right? Allows me to navigate to my new post, right? When I create a new post, I come back to this page. So I have these 2 pages, right, that allow you to see all the tweets, and one that allows you to post new tweets, right? So I have a button here that I can say the text might be post new tweet that navigates to new tweet. And I'll give it a color, maybe success, like greenish. Say, okay, there it is, right? So like we can try it out. We can notice that there's a triangle at the bottom that presumably allows you to run this, right, and test it. So this is what it would look like on a phone, right? The page, all tweets. If I click on post new tweet, it navigates to the new tweet page, right? Where you can type title, and you have this is supposed to be a text area. Text area, but it's not showing very well. I have my post tweet at the bottom, so I can type and put make things bold, maybe. Oh, I can't do it. Oh, how do you select on a phone? Oh, there it is. Okay. I can make it bold. Post tweet. Notice that it navigates to all my tweets, but it didn't actually create a tweet. I didn't actually create a tweet. Also notice that at the top right it has a cancel. Go back to my IDE. Right. I don't want to run this anymore. So this kind of quits and goes back to the page. Right. Actually, we can say that in new tweets, when you post it, we can say, hey, I want you to navigate to the tweets, but I also want you to insert. I want you to insert the content into some database, right, of whatever you're submitting, right? And in the tweets, right? I want you to display in a data table, right? Anybody have used data tables before? Anybody who's done Visual Studio? Anybody knows Visual Studio? Okay, only a few of you. Data tables allow you to point to a data source and say, okay, well, give me all the data that is in a particular database, right? I just want to display all the content that's in there, right? So this one allows you to say where. This one allows you to say where was the data submitted? It was submitted from my new tweet page, and the fields in there were title and tweet, I believe. Okay. And if I say okay, right, creates this data table, right? So that if I run this now, right, and I say new post, I can say my new tweet, and we can copy here maybe something from lorem ipsum. Where are you? Paste. Post and tweet, and there it is. Right, it actually posted the content in the database. Right, posted in the form of a data table, which is very hard to read, huh? It's kind of hard to read, but nevertheless, it did put the data in the database, right? So it's a full-blown application, implemented just with a couple of drags and drops, right? What could be even better than a data table, right? Even better than a data table. Let me remove this. Would be a repeater. Right? A repeater allows you to do it's the same thing as a data table, but you could give it a template HTML. Right? Where you could say, for instance, that as a header and the content as just plain old HTML. Right? It would be just a template. Fill in the blanks. Fill in the blanks. Right? So, for instance, I could say, grab the data from wherever it was submitted, and the fields were called. What were they? Was it title? Was it? Tweet, was it? Okay. Tweet. And here I can format and say that I want the title here, and I want the tweet here. Okay. I want this to be formatted. Oh, how do I? Oh, I can't select it. What's the gesture for selecting? Is it double tap? Yeah, but it only selects that on an iPhone. It gives you the selectors. Anyway, I'm gonna get out of the phone. It is what it looks like. So this is I'm gonna say that this is H2, right? And the rest is just a regular paragraph. So I say okay. Say okay. No, that didn't look right. No, I don't want both as headers. I want this as a header. I don't want this as a header. No, just a regular paragraph. Let me try that. All right, so if I run this, it doesn't work. Wait, let me edit. Collection is my tweet, okay. There it is, my new tweet, right? Format it like a tweet. So there you go. You can create a pseudo, Twitter application just with a couple of drag and drops. So we're going to be building this throughout the semester. Other things that we could build, all sorts of things, are maybe put some scripting in here, that you can run scripts. If this happens and do that, and all sorts of things. That would be really cool. All right. So that's what we're going to be building. Any questions so far? Make sense? Did I lose anybody? All right. No, go ahead. Yes.
What's behind it? You already built a lot of stuff, and you're demoing what you built.
Yes.
So what you built is this is what it would look like after you've done all the behind the scenes.
Right. Yep.
Magic is still.
Yes. The first assignments will ask you to implement the first 5 pages. Right. It'll ask you to implement the login, registration, profile page, websites, and pages. Yes.
We're all making this.
Yes, for the assignment. For the assignment. Right.
In the project as well.
In the project, my hope is that as you learn to do this, right, and learn how to do web services and Angular and the databases and all the relationships that we can implement, right? It says, ooh, okay, so now I know how to do this. Also, we're going to be able to connect to YouTube and connect to IMDb and connect to all different places to add things. And you will be able to then replicate and do your own thing. Yes.
So kind of like if you're doing this ideally, like I talked about yesterday, we'd be kind of making the login page and everything for this, and then also make the login page and stuff.
That'd be the ideal. The ideal is that in parallel, you would be implementing the same things, obviously for your particular case, for your particular domain. But yes, you'll need a login page. You'll need a registration page. You'll need a profile page. My domain objects are websites. Your domain objects will be restaurants or sports teams, right? Or whatever. Okay. And I'm going to go through some of the projects that some other students have built, so you get an idea of what can be done. A lot of folks have built things such as that are very similar to Yelp, right? Or IMDb for searching for movies, or connect to the music services, right? To play music, or all sorts. Everybody likes restaurants. I don't know. There's a lot of folks that like food. Some other people have done things like Expedia, right? That they can search for locations in the world. They can retrieve reviews about those locations, right? They can. Other folks have done some of the things like Uber, or a lot of really interesting things. Right? Yes.
Is it required to use like an extra, we were thinking that use our website to play chess remotely with 2 people.
Yep.
Like you each log in, and then you can make them go to the database. They can see that you made
Right. Yeah, so web APIs is not required for the undergrad. It is required for the graduate folks. Although I strongly suggest you do some kind of API. Although it doesn't have to be a third-party API. It could be somebody else's API. Maybe you're doing a project and you do another project, and you could be each other's communication, right? Or the service could be a service that you create, right? And you talk to this service that you create.
So it's like an API service that you could like log in on your phone or a different device and
But the
Yeah. So the ideal thing would be there that anybody should be able to connect, right? And for instance, use your chess playing. Chess? Yeah, chess game that you can all participate and collaborate in space. Yeah, very cool. Yes.
Yes, I have a question about how I get their windows every rendering. I'm using like Ajax, right?
Yeah.
And the data is updated inside of the model. On the
Yeah.
front end of the user.
Yeah.
That's live, re-render.
Right. So what happens is that Angular keeps track of the DOM elements that it's responsible for, right? And it understands what parts of the DOM map to what parts of the model, right? And anytime the model is modified, right, it's responsible for modifying the DOM that maps to it, right? So for
I want to call a re-render method.
no. What you do is that you modify the model, and as the model changes, the front end changes by itself, and vice versa. If you make changes to the DOM, the model changes over as well. So there's two-way bindings, right? So if anything happens to the DOM, if anybody removes things from the DOM, right, then Angular is notified. Or sometimes if you type something on an input field, right, and so it's changing, the events are notified to Angular. Angular knows that these things are happening. So let me just talk a little bit about the architecture of the application, which is somewhat the same architecture that we're all going to be implementing. Right, so let's see. Right, so the architecture looks somewhat like this. Right, so you have your server here. Here's your Node.js server. Okay, and here you have the user using the browser, right? So what happens is that we navigate to a particular URL which maps to a particular index page, right? So here's your index page. And this is the index page. This is the only physical file that will be downloaded, right? This is the only file that we ever actually navigate to physically, right? All the other files, there's several other files, index files, I'm sorry, other HTML files. They will not be navigated. We're going to be downloading, well, not us, Angular is going to be downloading each snippet, right? There's going to be, for instance, profile here, profile.html, right? And all these files, they're snippets, right? They're not meant to be used independently. They're not meant to exist on their own, right? They're only partials. We call them partials, right? The partial HTML files. Okay, so first we ask for index. That's the only page we ever navigate to. Right, it downloads, it gets copied here onto your browser. Now this page refers to several other resources, right? So as you come to here, you'll notice that it'll ask for CSS files, for JavaScript files, for images, for all sorts of icons, fonts, right? And each one is a separate call back to the server, ask for those resources. Some of those resources are not going to live on our server. They live somewhere in the cloud, right? Maybe they are AngularJS or jQuery.com or Bootstrap, or there's a whole bunch of other libraries that are not necessarily being hosted at our server. So the browser, as it's parsing our index file, it says, oh, I need to go get Angular from Google. I need to go get jQuery. Need to go get Bootstrap. I'll go out and retrieve all this. It will paint your page, right? So our page is going to be, this index page is going to be mostly empty, mostly empty, right? It's going to declare a common header, a common footer, and then an empty space. We'll call it. It's where all the other pieces of content will be strategically loaded at different times, right? So, for instance, as you have a navigation links, right, or as you click through the various clicks here, right, what will happen is that Angular is gonna look at the paths over here and is gonna map them to each one of these HTML files, right? So it will know to download one particular HTML whenever you navigate, right? And the mechanism that it uses to do this is, it's a very clever mechanism that it uses what is called the hash, right? When you have index.html, okay, the hash originally was meant to be used for linking content in the same page, right? For instance, you could create table of contents, right? You could create table of contents where at the top you would have intro, maybe a table of content, but like the intro, references, methodology, right? And each one of these links, right? The hyperlinks would be basically hashes, right? Hashes that would refer to different sections in your page, right? So like for instance, you would have ID equal intro, right? So by naming these different sections, right? Clicking on these hyperlinks would just scroll the page up and down, right? And jump to different sections of the page. Have you ever done that? Have you ever used that? Yeah, some of you. So you never actually left the page, right? You always stay in this page. So what Angular does, and not only Angular, many libraries do this, right? They hijack this behavior, right? And they create JavaScript event handlers around this. It says, ooh, I can be notified when these hashes change, right? When these hashes change. So but I'm not going to use it for this. I'm not going to use it for jumping at different locations in the page. Instead, what I'm going to do it for, what I'm going to use it for, is that I'm going to do a mapping. I'm going to do a mapping and say, if it's profile, I want to load profile.html. If it's websites, I want to load websites.html. But somewhere I need to configure this. I need to tell Angular and says, hey, that configuration, read that configuration, right? And if this happens, if this is the hash, that's the HTML that I want. If it's this hash, that's the HTML that I want, right? So now Angular takes over our entire page and says, okay, as I click through these links, what it's going to do, it's not going to refresh the page, right? What it's going to do is going to do an AJAX call. You'll do an AJAX call. Underneath, it'll do an HTTP request without leaving the page, right? Underneath, it'll make an HTTP request. It'll ask for profile.html, right? If it sees that hash sign, it comes back, and what it does is that it replaces the DOM. It says, I'm going to throw away the content of this DOM element, and I'm going to replace it with a DOM representation of that page, right? So as far as we're concerned, it behaved the same way as navigating from one page to the next, yes? Right? It looks like we did navigate from one page to the next, right? But we never actually left index.html. You see that? Right? And that's the core technique under the underpinning technique that allows us to do SPA, right? Single page applications, right? Allows us to have the same features of navigation that we're so accustomed to, that we're so familiar with, right? That we have hyperlinks, and hyperlinks navigate to different locations. We can have that same behavior, but maintaining without the reload of the page, a brusque, complete reload of the page, right? Okay, so that's one part, the navigation portion, right? The navigation portion. Now, the profile page, when it loads, it'll want to show me my first name, my last name, or information about the currently logged in person, right? Well, how do we do that? the information, when profile comes here, when profile is downloaded and is displayed here, it'll be just HTML, right? Just be ASCII. It'll be just a form, an empty form. Yes? But it won't have any data. Just be just static. So we need to fill it up with actual data. We need to fill it up with actual data, right? So a second mechanism that that Angular takes is that each one of these HTML files, is considered or is referred to as a view. Right? Meaning that this is only displaying content to the end user, right? Someone will provide the data at some point, right, to fill in that information, right, that is going to be displayed. So when it displays here, it's empty. The view is empty. Alongside with each view, there's someone who's responsible for providing data to the view, right? And we call those controllers. Right, so controllers are the ones who are responsible for fetching the data somehow, magically, and then providing that data to the view for rendering, right? And this mechanism of splitting these two tasks between views and controllers, right, falls under an overarching architecture referred to as the MVC architecture, right? As I mentioned briefly yesterday, MVC has been around for quite a while. It has proven very successful on server-side technologies, and it's a very well-known, very mature technique. And it's only now being discovered on client-side development, right? And so a lot of the ideas that have matured over decades, 10, 15 years, on Java or C# or on all these other frameworks, we're now copying a lot of those same ideas onto client-side developments, right? This was an architecture that allowed to split up the work in different into different teams, right? To think about the various challenges of each one of the different pieces of the application, right? Views, what are you going to display to the user, right? The concerns there were, how I'm going to lay it out, what colors I'm going to use, what fonts, right? How pretty I'm going to look like, the marketing and whatnot. And those are different skill set. That's a completely different skill set from developers that are thinking about event handlers and data modeling and arrays and objects and all these other things. It's a completely different set of skills. And the other one is the model. How I'm going to represent this data, how I'm going to store it, how I'm going to index it, and how I'm going to make the relationships between the various entities. So these are three completely different skill sets for each one of them, and it's a way to divide and conquer, right? Something that's very complex, right? We like to think about it in different buckets, and then say, well, you know about view, right? You know how to design, and you deal with the view. But in this class, we're going to be doing everything, right? We're going to be putting the hats of all developers here. We're going to be doing front-end development, back-end development. We're going to do everything, right? We're going to do someone who is familiar with all three is usually referred to as a full-stack developer, right? So anyway, so this has been around for quite a while. So Angular took over that idea and says, I'm going to copy that idea. I'm going to apply it here in the front end, right? The HTML is going to render the view, and I'm going to have a dedicated JavaScript file dedicated to that one HTML that you have right there. Okay. The view is going to have a couple pieces of data. The data are maybe the username, first name, last name, email, phone. Those are the pieces of data that I need, right? Somebody has to give me that piece of data. Who? Well, the controller will, right? The controller is tied to the view. When the view loads, this same file that configures, which hash will load which HTML, also allows us to configure, what JavaScript should load as well. hey, with that view, also load that JavaScript. Okay, so this AJAX call does both. You go, well, two AJAX calls. One will load the HTML, and there's another AJAX call will load the JavaScript. Right now we have both of them copied here. Right, and then in that JavaScript, you could what it'll do. That JavaScript, what typically you will do in here is that, hey, my view needs this data, right? Typically the URL will look something like, I'm going to the profile, and it's the profile of some user called Janunzi, meaning the name of the persons whose profile I want will be part of the URL, yes? Right, so I could grab that username from the URL. The controller can grab this user from the URL, and then now that it knows that you are the person whose profile we need, that controller can go back to the server and say, hey server, I have this username. I need the data for this username. I need the profile information for this username. Right? Over here on the Java on the server side. On the server side, we're going to define quite a few web service endpoints. Web service endpoints that are going to be waiting for these incoming requests. Notice that up to this point, everything we've been asking for has been static. Yes? HTML, JavaScript, CSS. This one is not going to be a static call. Right? We're going to be asking for dynamic content. We're going to be asking for dynamic data, right, to a web service, and the web service is going to do we're going to code here using JavaScript, code that is going to query the database. And query the database that says, hey, I need the profile for Janunzi, right? The database is going to respond with a JSON object. Okay, the web server is going to respond with the JSON object. The controller is going to receive that JSON object, right? And it's going to feed it to the view, and the view is going to finally render our information. Okay, let me just demo it real quick for you. If we go back and we see the network, so let me clear this. I say that. Notice that there it is. That's the call that went out to the server, right? And it came back saying that the information that it has is that, well, right now it only has the username, right? But let's add a couple of other things, right? Here we have Jose. And so I'm going to say OK here. If you notice on the right hand chatter between the browser and the server, I'm going to say OK. All right. Notice that there was another network connection. You see that? Right. If you click on that, you'll notice that the header there was a put. You see that? It was a put. Right. So on HTTP, we have several methods of communicating back to the server. We have gets, we have posts, we have puts, we have deletes. Okay, there's a whole bunch of actions. We're going to be using all of them, right? Put, in particular, is used when we are modifying something, right? Get, like the name suggests, is when we're getting something, when we're only doing a read-only, when retrieving data from the server, right? If it's a post, meaning we're creating something new, right? And delete, as the name suggests, when we're deleting. Right? Those are the 4 CRUD operations we will ever need. Right? Those are the only 4 operations that we'll ever need. Notice that here, information about the developer. Notice that it was a get. You see that? It was a get, and we were providing the information here. Also, well, I want to point out a naming convention. A naming convention is that whenever we're asking for data as opposed to static content. You know, instead of asking for HTML or CSS or images, right? Those are all static. Whenever we're asking for data instead, right? The naming convention is that we prepend all those types of requests with an API, meaning this is a very special type of query, right? It's not, I'm not asking for static content. This is meant for a database, some kind of database access, some computation on the part of the server, and the server will respond dynamically with that data. In this, notice that if I refresh, if I go to my website and I go back, notice that my query, PO, now my response now contains both last name, password, username. That wasn't there before, right? It's now in the database, right? So notice that page has never reloaded. See that? Notice that in our network call, we never saw the page actually refresh, right? We never left index. Instead, we're fetching the data, you know, strategically from the server and updating the content as necessary. Okay. Also, if I can clear this on the right-hand side, if I click on website, that the page didn't actually refresh, right? The page didn't refresh. It went out to the server and it asked for API developer PO and then application. You see that? API developer PO. The username is PO and then application. If I click on the application Twitter, notice that now the URL is what? The URL is application, the ID of that particular application, and then that page, right? So notice that URL has structure, right? It has a particular structure, right? It's the structure of the relationships between all these various entities, right? So when you create the data model, right, of creating those relationships, saying that a particular user has so many websites, right? A user has many applications or websites, and a website has many pages, and a page has many widgets, right? Because we're going to be asking for this data back and forth to update our websites, we need to come up with a structure on how to access this, right? We need to come up with an idea on how to structure all this data. One particular way that is very common is that the URLs are based on the entities, right, and their relationship. The hierarchical nature of the relationship between users and websites and pages and widgets is reflected, should be reflected in the URL. So for instance, if I want to access a particular user, right, I could say API/user, right? And this is a get. I'm retrieving get. Notice that if I do that, what would you expect? Which user would you expect? Well, I didn't specify which user, right? So the understanding, right, is that you want all the users. Right? You want to list all the users. Right? If I specify a particular user by ID, then this will retrieve a single object, right, that represents that one user. Yes? If I keep going and I say that I want, for that user, I want the website, right? I always like to use singular, even though you might be asking for many websites. I still like to use singular. If I don't specify which website, that should be interpreted as in I want all the websites for that particular user. See that? Right? If I specify which website by giving it an ID, then I mean just that one website. Yes? Yes?
Could you request multiple but not all?
Sure. Yes, like a filter.
Yeah.
Right? Okay, so typically to do filters, we would use query strings, right? Where this sets up the entire entity, right? And then you can specify filters, those that were created after whatever, right? Or only users that make so much salary or whatever, right? Or within a particular range, right? We could provide query strings to do that, right? And I can keep going, right? I can say now I want pages, the page, right? If I don't specify which page, then it's all the pages for that particular website, right? And so on and so forth. You see that? This strategy, right, allows us to navigate, right, any data point, right, in our database, right, starting, in a hierarchical manner. Now it gets somewhat more challenging when you're talking about many-to-many, right? So many-to-many, it changes a little bit, but we'll get to that a little later, right? So this strategy, right, we're going to be using throughout the semester, right? As each controller needs to fetch data from the server, right? We'll always be thinking, okay, what is my data model? What are the relationships, right? And knowing this map, right, it'll gives us an idea of what the URL should look like and what the server should be waiting for queries. Okay. Anyway, so get data for the pages. You'll notice that it received an array. See that? So there's an array of objects. Here's one of them. Here's the other one that are represented here on the left-hand side, right, as each one of the pages. All right. If I want to modify just one page and I click here, I need to go fetch that one page, right? That one page, right? There it is. Fetch that one page, and it's only one object. See, it's not an array. See that? Right, so we're always going to have two things, right? The HTML, and then the control that goes along with it, right? And the controller is responsible to feed the data to the view, right? It's responsible to go fetch the data from the server, right, and then pass it on to the view for rendering, right? The view should never try to manipulate data or somehow fetch data, right? That should be the responsibility of the controller, right? And the controller should never be responsible for the view, right? It should only be responsible for manipulating the data, reordering it, sorting it, searching, doing all the things that computing on the data, right? All the computational things, right? And it's a nice split, and you find a lot in the industry that it divides very nicely on the different skills of the various collaborators in a team, right? Anyway, I'm going to leave it here. On getting the template project up and running, the database. Again, tweet me, text me if you need help. I'll be in my office later today if you want to come and chat. All right. Thank you. Let me stop this.
Oh.